Hi everyone, welcome back to my channel. So today we'll be going through another tutorial on TI Inspire CX2 CAST calculator on math methods unit 3 and 4. So today we'll be going through the transformation topic, and this is on exercise 3D, question 7. So in this question we have a function of y equals to x to the power of 1/3, and we have a series of transformation. And then we need to state the rule of the image with the sketching of the graph. So let's get started. So in this case, we have a reflection in the y-axis first, and then followed by a translation of 1 unit to the positive direction of x-axis and 2 units in the negative direction of y-axis. And then we have a dilation factor half from the y-axis. So let's write this out. So we have first our x, y coordinate, which then has a transformation of reflection in the y-axis like this. And then we have a translation of 1 in the positive direction of x, so negative x plus 1. And then we have y minus 2. And then finally, we have a dilation of half from the y-axis. So this would be negative half of x plus 1. Oh, sorry. So the negative is inside the bracket. So this would be half of negative x plus 1, and this is still y minus 2. And then what you want to do is you need to write out the x dash equals to the half of negative x plus 1, and then the other one is y dash is equals to y minus 2. And then we've got 2x dash equals to negative x plus 1. And the other side is the y is equals to y dash plus 2. And then you basically just make your x, y subject. So negative x is equals to 2x dash minus 1. So x is equals to negative 2x dash plus 1. Then the other side is still the same. So we've already made y the subject on the right hand side, and then on the left hand side here we've got x the subject. And then we just transfer this information to our original function to find out what's the new function under the transformation, like sequence of transformation. So when we sub y in here, so we get y dash plus 2 is equals to, and instead of x, we've got negative 2 x dash plus 1 to the power of 1/3. So our new image or our new function is y dash equals to negative 2x dash plus 1, 1/3 minus 2. So that's our new function. So, and then we can type that into a calculator. So let's go ahead and do that. So I've got my calculator here. And then basically we go to our graph sheet here, like this, scratch pad. And then we type in, so we double click a blank space, and then we type in our new function. So we've got, in this case, y equals to, and then just put bracket negative 2. So negative 2, and then x plus 1, and then the whole thing to the power of 1/3, and then minus 2. And then we go ahead and press enter. And then if your graph doesn't show straight away, so you can always just go to menu and then go to zoom, and then go to auto fit like this. So you can do that, press A to auto fit. And then once the graph pops out, you should get something like this. And then to fully do the graph, so you need to know your y and x-intercept. So to find the x-intercept, you go to menu, go to analyze graph, and then press 0. So you go to 1, 0, press 1 there. And then you select your lower bound like this on the left-hand side, and then press it once. And then upper bound should be past the like the negative end of the y-axis, and you can see a black dot there, meaning that it's calculated the x-intercept. And then you just go ahead and press enter, which is then negative 3.50 is the coordinate of your x-intercept there. And then to find the y-intercept, you go to menu, you go to trace, and then you go to graph trace. So you can just press 1 there. So go ahead and press 1 there. And then, so you get this blue cross and circle, and then you just press 0. Then it says here x equal to 0, and then you just press enter, and then you just double click that, and there you have it. You have the y-intercept there. So yep, so we pretty much got all the coordinates there. And then so we also have a point of inflection. Originally it was at 0, 0, but now it's been shifted because of the transformation. So we should be at, in this case, half and 2. So let's go ahead and draw that. So I'll just bring up my screenshot again. That's over here. Okay. Then I'll just bring that up. Cool. All right. So let's go ahead and just graph that. So we've got this one here, and then this is X, this is Y. So the original graph looks something like this. So it's like that. For y equals to x to the power of 1/3. So it's almost like a cubic graph, but because it's the power of 1/3, so it's a lot kind of like slower. So if it's a cubic graph, it will look something like this. So that's x to the power of 3. But because it's x to the power of 1/3, so the power is like a lot smaller. So it looks something like that. And then because this is reflected, so we should be expecting which we already have from the graphics calculator. So if it's reflected, it'll look like that. And then because it's been translated basically by half, and then it's been shifted down by 2 as well. So in this case, if we kind of rewrite this one, so if you take out the -2, then you can see that it's x dash minus half, and then 1/3 minus 2. So therefore, the turning point is now at, or the point of inflection is now at half comma -2. So we can go ahead and draw that. So that is our point of inflection. So let's say this is -half, and this is 2. And then we also know from the graphics calculator, from the TI Inspire, is this is -3.5 for the x-intercept. And for the y-intercept is at -1. So that's -1. Okay, so oh sorry. So this is so the turning point. So I'll just redraw that. So the y-intercept is at -1, and this is -2, and this is half. So that's our point of inflection. So it's gonna look something like this. Something like that. That's the point of inflection. So this is half and -2. And our y-intercepts at -1, and our x-intercepts at -3.5. And that's it. So you just take that out because that was just for reference. So that will give you the full marks for this question. If you've got any questions, feel free to comment down below. Otherwise, I'll see you in the next video. Okay, see you later.